Without using calculus, sketch the following polynomial function showing the behavior near any x-intercepts. P of x equals x minus 2 all squared multiplied by x plus 2. First, we find the leading term. Look at the first bracket, its leading term is x, we raise it to the power of 2, we get x squared, multiplied by the leading term of the second bracket, so it's x to the power of 1, which is just x squared times x is x cubed. The degree is 3, with a positive leading coefficient. The graph will stretch from quadrant 3 to quadrant 1. So this is a cubic curve. Next, we find the constant term in a similar way to finding the leading term. So go back to our function. We'll look at the constant term in each bracket and we multiply them together. So negative 2, we raise that to the power of 2, multiplied by positive 2 to the power of 1, and we get positive 8. So the y-intercept is 8. Next, we find the zeros and their multiplicities. So the first linear factor, x minus 2 all squared, we set that to equal 0. We get x equals 2 as our first zero with a multiplicity of 2. And our second linear factor, x plus 2, set that to equal 0. X equals negative 2 is the solution, and it has multiplicity 1. So this is a double zero, this one's a single zero. Finally, we sketch the graph. Now at the 0, where x equals 2, or the x-intercept where x equals 2, it has multiplicity 2, so therefore the curve will touch the x-axis and bounce off. And at the 0 where x equals negative 2, it'll behave like a linear function, so it'll just cross the x-axis without being tangent to it. And we also know that the graph will stretch from quadrant 3 to quadrant 1. So one strategy would be that at the zeros, I would just draw maybe just a small parabola looking shape, just where positive 2 is, and where negative 2 is, just draw just a line that just crosses through or passes through negative 2. Now we don't know where the turning points are precisely because we're not using calculus, so we're not concerned about that, and it does not have to be drawn to scale either. And then finally, just neatly sketch it so that it looks like this particular cubic curve or something similar to it.